Okay, first derivative test. I have to make a sign chart, and I have to look at the before, I have to look at the after, I have to look at the increasing or decreasing before, the increasing, decreasing after, and then say, as long as it's at a critical point, this is true, this is true, this is true. Second derivative, I do not have to make a sign chart. Why is that nice? If you're given a problem like this, guys, what have they basically done since the beginning of the problem? What have they given you?
Oh, it tells you what we're looking for.
It tells you your answer. It says, hey, this has a relative min at, show us how. Well, let's actually start with our second derivative test, then I'll do a first derivative test and say, well, this is what you would have had to do. To do the second derivative test, first of all, check our domain. What's the domain of sine squared? What's the domain of sine, and then square all those domains. Domain of sine is all real numbers, square all real numbers, and you still have all real numbers. So, any problems? Nope. So they're going to make a fool out of us with this one? No. If it was tangent, still okay at 0. If it was pi over 2, we'd be in trouble. After domain, we need to find our critical point. But to find our critical point, what do we have to, our points? Hold on. Pause. Let's just find our first derivative, right? Because to find our critical points, we need to find our first derivative, set him equal to 0, or find where he does not exist. So my first derivative is chain rule. What do I have? 2 sine of x times cosine of x. Good. Bring down the 2, multiply it by, keep the inside sign, times the derivative of sine is cosine. If I really just need to test at x equals 0, guys, what do I really just want to know? Is this a critical point, true or false? If I plug in 2 sine of 0, cosine of 0, what's sine of 0? 0, what's cosine of 0? 1. 2 times 0 times 1 equals 0. Check, I can say, hey, he's a critical point. Just because he's a critical point, does that mean he's a minimum? Nope. A maximum? Nope. Neither? Maybe. So second derivative test says, good, you checked the discontinuities, you found the critical numbers. Well, I just checked to make sure he was one. I already know he's the answer. Second derivative test says, okay, find the second derivative. What's f double prime? Okay, that's the dilemma of the second derivative test. You have to take another derivative, which as we know can sometimes be messy and not worthwhile. Well, if we can avoid it. But sometimes derivatives aren't too bad. This one we can do. He's not the nicest, but derivative of, product rule, derivative of the first, cosine. 2 cosine times cosine, 2 cosine squared. Derivative of the second. Derivative of cosine is negative sine times 2 sine would be negative 2 sine squared. Second derivative test. Check the discontinuities, find the critical numbers, plug the critical numbers into the second derivative, and check your concavity. What am I plugging in to check? What is f double prime of 0? 2 times cosine squared of 0. Cosine of 0 is 1. 1 squared is 1. And 2 times 1 is 2. Minus 2 sine squared. Well, sine squared is just sine of 0 is 0. Wait, what does this tell me? Second derivative at 0 is 2. So what? It has a sign, and its sign is positive. And since it's positive, if I look back at my test, or if I think about it logically, wait, second derivative positive, my original function is concave up like a cup. I have a critical number. What must x equals 0 be? Minimum. So I can say, sweet, there is a relative min at x equals 0 since f prime of 0 equals 0 and f double prime of 0 is positive. And if you really wanted to get into more explanation, you could say and or, which indicates, if you want to be really snazzy, even though you don't need to state any of this, because they know the second derivative, if it's positive, it's concave up, it's a relative min, they're like, good job. But if you really want to be specific, which indicates that f is concave up at x equals 0. But that's more for your sake, not so much for mine or an AP grader. Did I prove conclusively that there's a relative min at x equals 0 of my function? Yes. How? He's a critical point. He's a horizontal tangent or an undefined. The domain is all real numbers. Don't have to worry about discontinuities. My second derivative is positive. He's concave up with a cup at a horizontal. He's a relative min. How would I had to have worked through this if it was the first derivative test? This is second derivative. No sign chart, just plug them in and check them out. And say, hey, what's your concavity? And say, okay, therefore, first derivative, I would have had to make a, starts with an S and ends with an I chart.
Not even sign chart.
I was trying, you guys weren't saying anything. First derivative, I would have had to take my first derivative and say, all right, let's just stay here at f prime of x equals 2 sine of x cosine of x. I would have had to solve for his zeros. I would have said, you know what, I know they're telling me to check out 0, that's all well and good, but I also need to know the intervals on either side to know how to check the signs. I have to have legal intervals to check. I'm going to check before and after 0, but what are the points that split up? How do I find the zeros of this? I set each factor equal to 0. What is sine 0? 0, pi, 2 pi. Negative pi, negative 2 pi. 3 pi, 4 pi, 5 pi. Negative, okay. All the pi's. Here, why don't we just do pi n? Does that sound good? We'll be all snazzy. You guys remember from last year what's n stand for? Positive and negative integers, counting numbers, not decimals, or else it's not coterminal, right? Cosine. Where's cosine 0? Where's cosine 0? Not 1. Pi over 2, 3 pi over 2, right? So I could say, all right, and at x equals pi over 2 plus pi n, because it's 180 apart. What are going to be the closest intervals, the closest zeros of the derivative, the closest critical numbers to 0? Who's smaller, him or him? I would have had to figure out, ooh, pi over 2 is on one side, negative pi over 2 is on the other. Then there's pi, then there's 3 pi over 2. But I don't need all those. I only need to look right here. I'm zooming in on this part of my sign chart. And I'm saying, hey, what's the sign of f prime? What's going on with f? And I could have plugged in and I would have figured out what is he a min. Long story short, he's going to be negative decreasing, negative first derivative decreasing of f, positive increasing. Then guys, the rest is history, right? True. Okay. Do you guys see how the second derivative might have saved us a little bit of work on this one? Maybe? Maybe not? Do you see how the second derivative might have saved us a little bit of time? Because what's the difference in the two tests? Second derivative says, domain, critical numbers, plug in, what's his concavity? Plug into what though? You have to find the second derivative. First derivative test says, you only have to find one derivative, then you have to do a sign chart. I don't know. They have their own individual pros and cons. I'd love to talk about him. Sure, why not? AP question. You guys ready? It's not a multiple choice, but it's a whole lot like one that the AP guys might throw at you. Question. What are you given?
A graph of the
Don't stop there. A graph of
first derivative.
Woo.
Sorry, that was close.
Guys, you guys.
Do crayons.
Well, crayons don't show up very good
I
unless I
like
do
it.
something dark. I'll do that. There you go.
Thank you.
Oh.
The graph of f prime.
Read the directions.
To estimate all values of x at which f has a relative min, relative max, and inflection point. Let me give you guys a couple moments. We'll say like 60 seconds to deliberate. You may talk it out, or you may individually just ponder life. Where would F have a relative min, a relative max, and inflection points? If you can get one of those answers, it'll be pretty awesome. Big moment. Focus your attention. Not on comebacks, but on use the graph. It has plural because there's multiple questions like this. My English grammarians. May deliberate with others if you so wish. Ponder. Great AB. In just a moment, I'm going to try and take that graph and go to a sign chart. Once you get used to these types of problems, hopefully you won't have to do that every time. But just for you guys to see what my brain is going to think through, and maybe what some of your fellow classmates' brains are thinking through as they're trying to answer these questions. The sign chart is one of the easiest ways to visualize. So if some of you guys are totally stuck, start thinking about how would I make a sign chart for, how do I use this graph to get there? Not really random at all, but. How many of you guys think there's a relative min around zero-ish? If you think it's around zero-ish, what are you mistaking this graph for?
Oh, F. Got it.
If this was F, oh, a max and a min and a max, and look, there's like a point of inflection here-ish and here-ish. It's not pre-cal. They're not giving you F. What are they giving you?
F.
So I can't say max, min, max. Does anybody have a location of a min? Danny? Yes. There's a min at 1. Does anybody have a location of a max? 5.
Oh.
Does anybody have a location of a point of inflection? I'll come back and I'll explain. Tanner?
I'm just guessing, but it seems like 3.
Yes, 3.
And
There's
like
one more. And?
0-ish.
No. Ah? Yes, 0-ish. And at -1. Why? Question. What are the signs? Well, hold on. What are the zeros or D&E points of my derivative? That's my critical numbers, right? What are my zeros? -1, 1, 5. What are the signs of the heights from -infinity to -1? The signs of the heights are negative, aka F is decreasing. In between -1 and 1? Negative, aka F is decreasing. In between 1 and 5? Positive. Oops, that's in the wrong place. I apologize. Positive. And then 5 to infinity?
Negative.
So, why is there a minimum at 1? Because my derivative changes from a negative to a positive, aka my F changes from a decreasing to an increasing, which I can see in my sign chart. There is a relative min at the 0 of the derivative, where the signs change of the derivative. And there is a max at, this is what my brain does. Oh, hey, increasing and decreasing, got it. 5 is a max. Hold on. How did you guys with points of inflection, how did you figure that out? How do I see points of inflection? Ooh, second derivative. Ooh. How do I see a second derivative on a derivative graph? Question, do I have any 0 or undefined slopes? I have one at -1. I have one at 0-ish. Sorry, it probably should be 0. And I have one at 3-ish. I have a horizontal slope, and a horizontal slope. Question, what is the sign of my second derivative from -infinity to -1?
Positive.
Because the slope is positive. Good. Positive, aka concave up like a cup for the original. What's the sign of the second derivative in between -1 and 0?
Negative.
Negative, then positive, then, still positive, then negative.
Negative.
So, hold on. Negative, which means concave down. Positive, which means concave up. And then negative, which means concave down. Where are my points of inflection? Boom, boom, boom.
Boom.
Great AP question. Why was it hard?
Because you
They gave you the graph of
Derivative.
the derivative, and they said, hey, what's F doing?
Oh, no.
All right, cool kids, homework number 22, work on tonight. What did we not get to? Oh, we didn't get to like one problem, let's just do the test. I'll go ahead and do this one problem, let's do the test during lunch. I'll put it online if you guys want to see it. Otherwise, doodles, finish, study. I'll be here after school.
On the graph, when it says on the sign of F prime, for the sign for negative 1, how would that be negative?
Sign
Right there.
before or after -1?
Right here.
Before -1? Why is it negative? Benji, the slope is positive,
Yes, I'll wait in my already.
but the height is negative.
Are you buying lunch?
The slope is positive,
Lame.
but the height is negative because it's below the axis. Remember, the y's are the derivative.
Do it at all?
If it's a derivative graph, the y's are f prime. So if I go -2, it'll be a negative number. It'd be a negative number.
If you're following the x-axis.
So the slopes are positive, negative. The slopes are the second derivative. The height above or below.
That's my first time.
Only for giving the graph.
I don't understand the second derivative when it comes to the concave up, concave down. Isn't it supposed to be like that one spilling water, that one holding water, in the sense that
Hiking, seeing, square.
because I'm observing this and it says that it's positive, right? We're referring to this, but in this like
The slopes sign.
well, since that would be positive, right?
So you could just look at this and say it's a positive slope, so then my second derivative is a positive slope. Or I could say it's increasing, because f prime is increasing, which means his derivative is positive. Slope.
And then that's decreasing, so that would be
So that'd be a negative derivative.
and that becomes positive.
Increasing.
But that's too positive. Oh.
Yeah, because it's this whole thing. I was looking here and I'm like, oh wait, sorry, the whole thing. I would have drawn a line here. And that's why I have from 0 to 3. It's like this whole part. It's increasing, aka derivative positive.
Please tell me you're staying at lunch, please. Okay.
Yes.
I have like a lot of cash checking to do.
Ooh, if you go in the back, you see the trays with lots of papers in them?
Yeah.
It's the bottom of those trays in the like orange yellow folder.
And then for this,
Yeah.
to find the inflection point, should I do it this way where you can find 0 at 0 and then
Well, not these zeros, not for inflection points. These
this
zeros.
0? Then is it all the inflection point? Should I
Where it
prove
change. This was me showing reasoning for those who didn't understand, but in the future I might just say, hey look, change, inflection point. Change, inflection point, change, inflection point, without all of them. But this helps us write down what I'm looking at when I say, oh, it changes signs, that means concavity changes. So I was showing like all of my reasons, all of my things.
if I find like second prime of that and then it goes negative and it's but it's like negative in here, so is it positive?
No, because just look. Slopes are just negative, Don't overthink, just
Thank you.
make. Pondering. It's a rough one. And even those that said they got it today, they're gonna forget it later. The part we have to get down to understand where all of this is coming from is, first of all, he's a derivative. Second of all, his tangent lines
Thank you.
point to
Steve.
F double prime. You're welcome. So his slopes point to F double prime. And his heights, below is a negative, above is a positive. His heights point to his sides. I know. It can become easy, but it takes time to grasp. It can become easy, but it takes time.